Thank you, everybody, for joining us today. We have a really good session with Rakesh and Sam. I'm going to let you guys do your own introductions, but I'm excited to kick this one off and talk about serverless cost optimizations based on real life. I think I added that to your title, but I know it comes from real life. I know what you guys do. So, uh, without further ado, whichever one of you is leading, kick it off for us. I'm going to step off of the stage, and you guys just summon me if you need me.
Sure. Good. Yeah, I think we'll do like a brief introduction. Rakesh, I'm not sure whether you've got any like intro slides with avatars or anything, but I think we'll just introduce ourselves. And then so the way this is going to work, guys, is we want to sort of have a mixture of some theory. It's always good to learn some theory. And then we wanted to bring some real world examples of how both of us have had the opportunity to save a lot of cash when it comes to our service architectures. So we're going to kind of have like a sandwich approach. I'm going to start with maybe 5 minutes of like very basic theory. I think what Rakesh has got to say today is going to be really, really interesting. So once I've done my theory part, I'm going to hand the screen over to Rakesh. And he's got some great theory and examples, which will, I think, take up the bulk of it, maybe, not too sure. And then afterwards, I've got a nice anecdotal story to bring us to our closing points. So, Rakesh, you want to introduce yourself first, and then I'll introduce just before I kick off my side of things.
Sure, Samuel. Actually, I have my slides in my presentation, so I'll go through it during that introduction. So if you want to start your presentations, I'm perfectly.
Okay, sure thing. Right, let's set this up again. Okay, so just got some slides, some prompts. I think so. Rakesh has got some really interesting points, and I think they're really, really neat. Fundamentals, some fundamental understanding, some fundamental theory that a lot of us maybe just looking at who's on the screen. I recognize most people here from around LinkedIn. You guys have probably been doing serverless longer than me. So I'm going to gloss over a lot of this, but I do want to sort of establish some fundamentals. So let's start with the basics. You guys can see my screen changing, right?
Yes.
Yeah, perfect. All right. I guess actually let's introduce myself before I get going. So my name's Sam. This is my debut in the #BelieveInServerless community. So I'm really excited to be here. Very thankful to the guys that offered for me to come and co-host with Rakesh. I'm a developer, solution architect at Serverless Guru. We provide development, consultancy, solution architecture for serverless clients around the world, big companies, small companies. We do a lot of fun stuff on socials. Jonathan, I can see he's our marketing guy. He's in the chat. So, hey, Jonathan, thanks for jumping on. And yeah, I've been doing serverless for, I'm not sure how many years on and off. Started more DevOpsy, but moved into sort of development just over a year ago, and then very recently moved into solution architecture, which has been very exciting. Anyway, let's kick things off with some basic fundamentals that I will gloss over relatively quick. So we've got a very basic architecture pattern for serverless. We've got API gateway, Lambda, DynamoDB. Using serverless, we of course have this pay-per-use model. So if we want to reduce costs, then what we want to try and do is actually use our resources as little as possible. So let's start from the bottom of our stack on the right-hand side, DynamoDB. We want to minimize the amount of storage, essentially. You can do all sorts of TCLs that will allow you to have sort of automated garbage cleanup of stale data. And of course, there are these RCUs and WCUs. So you want to actually make as little calls to your database as possible. So you can apply some caching to your DynamoDB. So that'd be a DAX cluster. And that means that you have less end-to-end calls that are actually going all the way through to your database. Then we move to the Lambda. Lambda is going to be our compute portion, as we know. So kind of a little bit of an asterisk here, as you'll see from the next slide, but we essentially want to minimize the duration of our Lambdas. We get charged for how long they're running, and as well, how many invocations of a Lambda that we have. So again, applying some caching in front of this, so we only call our Lambdas when we have to, will also reduce some cost. Way that you can do that is then implement some caching, maybe in API Gateway. And then speaking of API Gateway, we move to API Gateway. So again, you get paid for the number of requests that come through. So you want to maybe do some caching on the client side of things. Now let's talk a little bit about Lambda power tuning. very, very quick because I know it gets covered a lot in the community. Very basic slide for those of you that don't know. It's an open source, free to use tool that allows you to right size your Lambda functions. It will deploy a certain Lambda function with all different memory configurations that you can see on the x-axis. Sorry, Rakesh, you just want to mute yourself. No worries. Perfect. No worries. It will run the Lambda function against all these different memory configurations. And then you get this really nice graph here, which is showing the invocation time for each configuration on the red, the red line, the red best fit line, and the invocation cost on the blue. And usually you can get to a very happy medium where actually you can actually save money whilst actually increasing the amount of memory that you're configuring for your Lambda function. So really nice tool, really cool. I'm not going to talk about it too much more. Definitely just use that if you've got Lambda functions, you're not quite too sure whether they should be big and beefy or small and light. I'm going to bring something a little bit different. I don't think it gets talked about too much. This was a graphic that I shared on LinkedIn maybe about a month ago. So this sort of came from when I helped run an LLM chatbot-based hackathon around Christmas with Serverless Guru, and we had to build a Santa-themed chatbot ourselves. And I had a ton of fun doing it. I learned a lot. And one thing that we had to make a decision over was how our backend architecture would look. So if we look at essentially the problem that we're trying to solve here is that LLMs are an extremely slow API. The same can be said for things like payment APIs, can typically be known for that. And of course, within sort of large enterprises, with all the spaghetti code going on, who knows, and all the networking, who knows what other extremely slow APIs we have to deal with in serverless. And of course, going back to that slides a couple of times ago, you want to minimize your Lambda duration times. So a naive person would probably come to this problem and go with option 1. So you have your API gateway, behind that your Lambda function, and within your Lambda making sending a prompt to probably Bedrock, waiting for that very slow response in the order of 10, 20 seconds, and then returning that to the client. A lot of problems with that. You of course have that Lambda function sat there idle, building up more and more as it's waiting. So one thing that you can do, I don't think this improves cost, but it's a cool pattern, is option 2. So you can leverage the streamed response from APIs such as Bedrock so that you can get that time to first byte sent to the client as fast as possible. And so they implement this on ChatGPT. That's why you start to see this illusion that there is a typed response coming back from ChatGPT, rather than waiting with a blank screen for 10, 15 seconds and then seeing a huge blob of text. They're kind of feeding it to you so that you can kind of read it as you go, and you don't notice that there is this long wait. Doesn't really help with cost though. The Lambda's still going to be running for the full amount of time. So we thought it's probably a better way, which brings us on to option 3. So, and this is actually what we use for our example. Our example project is we wanted to use WebSockets. So the benefit of that is that we have portion 1 from, if you're following on the screen, from architecture 3. So our request comes in from our WebSocket API to our Lambda function. Lambda function is going to send an event to event bridge. After that, it's sort of send and forget. It can now respond with a sort of good response, even though it's a WebSocket. So I'm not too sure if it even needs to respond with anything. Can't quite remember. But what we then have behind the event bridge, listening for that event, is what's going to actually invoke the Lambda function. And the reason that I've used a smaller Lambda icon is because you can now configure this Lambda to use the minimum amount of memory available. Because all this is going to be doing, it's going to be very lightweight. It's going to be calling our slow API, and it's going to sit there waiting for a response. And unfortunately, when you're using things like Lambda and slow APIs, you kind of have to sit there and wait. It's a synchronous request. But by using the smallest Lambda possible and decoupling the bulk of the application from what's going to be sat there idle, we are actually kind of going to be saving a bit of money. It's just kind of similar. It's by no means the same, but it's one of the arguments for using things like Cloudflare workers for this kind of architecture, because you just pay whilst the CPU is sort of running. So whilst it's there idle, it actually stops your billing, which is quite a nice pattern. This is the closest that I could find that we could get on AWS. And now we move to something slightly different from architecture 4. So this is going to be leveraging step functions. And if you're using Bedrock, great. It's a natively supported AWS API request. So as one of your steps in your state machine, you can make that call to Bedrock and wait for the response. And if you're using a standard workflow, you only build for state transitions. So if a state itself is going to take 20 seconds, it doesn't cost you anything extra. So that was quite a nice pattern as well. And if you're using a third-party API such as OpenAI, then luckily they released the third-party API web request state within the last 6 months or something, which allows you to then do a call natively within your state to something like OpenAI, which means that you don't have to wrap the request in a Lambda function, calling OpenAI, and then we just go full circle back to point one. We're sat there idle in a Lambda function. So this is something new that I wanted to bring. You can apply it to LLMs, payment APIs, anything that's going to take a long time. Just another little bit of theory with a minor example. So Rakesh, at this point, I'm going to hand things over to you. This was sort of my little theory section, and I'm going to come back at the end for a little story from Serverless Guru. So I'll hand things over to you now and stop presenting.
Cool. Thank you, Samuel. You guys hear me properly, right?
Yeah, we can hear you loud and clear.
Okay, cool. I'm gonna share. I had a little issue about my presentation, so I'll try my best. Let me know when you see my screen.
Yeah, we can see it. It's all good.
Sorry?
It's all good. We can see your screen. Yeah.
Okay, cool. So I'm gonna talk about the cost optimizations with AWS. We had a 25% cost reductions of our annual budget in 2023. We had a great experience at the Kubernetes solutions. So we're gonna give you a couple of examples that what are the things we have done it in 2023. Quick introductions about myself. I'm Rakesh Sangvi, having a 25 years experience in IT. Done with the multiple roles in a prior with the lead, with the Java architect, enterprise architect. Currently, I'm as a director of architecture team at the Kubernetes Solutions. I'm using AWS ecosystem since probably 2018, a little bit before that too. I'm AWS Certified Solutions Architect Associates. That's my LinkedIn address. That's my Twitter handle, and AWS mantra is it's my blog. I haven't, to be honest with you, I haven't posted since last couple of months, but I promise that I'm gonna do more blogging this year. This is what we're gonna go through today. What the cost optimizations cultures we have at the Kubernetes Solutions. We have a ECS, RDS, and EC2 cost. We have a server startup and shutdown for the lower environment. So we'll talk about that one. We use pretty heavily ECS port instances. So we'll talk about that one too. AWS Lambda optimizations. This is one of the best and one of the best one you can get it from this presentations. We have 170 million Lambda executions. That's costing us less than $150. So we'll go through a little bit more in details about how we did it. We'll talk about CloudWatch costs, SFTP, EBS volume, and there are a couple of others cleanup we have done it. Before November 2022, none of us from my team had experience with cost optimizations. So if I say something BS, please bear with me. Cost optimizations cultures. Current solutions.
Rakesh, can I just stop you? Your screen's not updating for me. I don't know about anybody else. I'm seeing you're still on the intro screen for me. Is anyone else saying the same? Okay. So
are you sure?
I think, yeah.
Let me
do that between each slide.
Let me do it one
more.
Yeah,
you're fine. No worries.
Okay. I'm gonna do it one more time.
Okay, so whatever you did to move slide, just do that each time and you'll be great. Okay.
You good?
Yep.
Do you see? Okay, cool. So we develop the cost optimization cultures within the Current solutions. DevOps teams we meet every 2 weeks for the cost reduction. So what we do it is when we meet, we identify the resources which we can optimize, whether it's EC2, whether it's EBS volumes, or whether it's a S3 bucket. So we identify all the tasks which we can perform on the following week. So on the following weeks, we can perform that actions in a production environment or in a lower environment. And so we continuously doing since last 2000 November 2022. We consider all the cost efficiency as a non-functional requirement. So we do the cost estimations as a part of our well architecture documents actually. As I mentioned, it's a small company, so everybody is having access to the billing dashboard. Maybe it's not feasible for the bigger company, but in my company we have access to billing dashboard for everyone. We do the cost allocations model for all our resources. So every team knows that how much total costing their resources based on that team as well as the services. Recently, what we did, we have quite a bit resources which is on tag right now. So we wrote the state functions to tag it all the resources. So we are not there 100%, but probably in the next couple of weeks, probably we will have all the tagging for all the resources. So let's talk about the ECS, RDS, and EC2 server startup and shutdown. We shut down all our lower environments. So we have a environment like a dev, QA, staging, and production. So we shut down all our lower environment. We wrote the script for shutting down. So usually it's like it's coming up morning 7 o'clock, and probably it's going down around 8 o'clock. We did it around probably November 2022 about all this shutdown environments. When I started the cost optimizations, I see that that ECS costing us during the off hours as well as the weekend. So we started looking at what exactly is happening with why I'm having a charges for the ECS during the weekend and during the off hours. So what we realize is basically we have almost like a 40 Java services. So what it is happening out of 40, 3 or 4 services, which is a pretty resource intense. So when we were shutting down the services, that 3 or 4 services was taking a little longer time to shut it down. Meanwhile, what was happening it is the scale of instances was alerting and it's starting a new task. So what happened actually it is at the 8 o'clock at the evening time when the RDS instance, ECS instance, and EC2 instance we were shutting down at the same time. When the new task starts, it doesn't find out the RDS connection because RDS was shutting down that one. So what was happening actually it was keep on recycling all our ECS instances, at least for that 3 or 4 services which it's spinning up the new task actually. For that reason, what it is happening, it's downloading the Docker file again and again till we bring up the services next day morning. In case of a weekends, it's keep on downloading the Docker files 24/7. So we fixed that issue. So now the usage of our ECS went down significantly. Now the second things you can see on my slides here, we use
Rakesh,
yes.
sorry, can you update your slides again? Just give it a bump. Still seeing the cost optimization culture.
You don't see it, my server startup and server shutdown?
Not yet, no. I think you need to go off of the presentation and just scroll through it actually in the software itself. That's it. If you scroll through there.
1 second.
Now we see Lambda optimization.
Okay. Okay, I'm gonna go up then.
So we come
Okay.
back.
Do you see this?
Yeah.
Server startup?
Yeah.
Okay, cool.
Yeah.
Good. Okay, so let's come back to the ECS Sport instances. So we use for all our lower environment, we use the Sport instances. As of now, we run probably around 100 tasks in a lower environment. ECS Sports instances gives us 70% discount upfront. You don't need to do anything. You just declare your task as a sport instances, and they are good to go. We use pretty heavily. I'm saying basically all our resources, majority of the resources there in US West too, and we are running this 100 tasks since last probably more than a year, and we never have any issue with capacity on a US West too. If you run one ECS task with the 2 gig memory and one CPU, cost around $32. If you run the sport instances, it's cost around $9 a month. And basically, it's for us, it's much cheaper because we just bring it our lower environment, probably 11 to 12 hours. So it's much cheaper. So because of the server shutdown and server startup issue, and ECS Sports instances, we save probably close to $18,000 per year. The reason it is, so we do the compute savings plans with the AWS. So we do the X number of amounts we spend per hour. We do the commitment with AWS. So because of the UCS usage came down, we were able to reduce by 2 hours for our compute savings plan. So that's why that that's $2 plus the sport instances is saving us the $18,000 per year in 2023. So this is the screenshot from the billing console. You can see here that basically this is a 2022. So why? Because we started the optimization. So you can see 118,000 hours per month we were using. Because of that, we fixed the script. It downs to the 62,000 hours. This is for all our environments. Okay. You can see here the sport instances. As I mentioned, that we started heavily using all the lower environment, all the ECS tasks is running the sport instances. So in November 2022, we were running like 8,832 hours, and it's jumped to the 70,000 hours. So you can imagine that.
Sorry
Yes.
to interrupt again. It's not up, so we're still seeing server startups shutdown, but we can see your mouse, which is weird. There we go. Now we see NAT gateway.
Okay, so give me a second. This is a good? Then probably I'll do with this one. I don't know what's happening. How about
If
this?
you want to do every time you switch slide, just ask us and we'll let you know once it's updated. Sorry to interrupt.
Okay, no worries. I'll do that 100%. Okay. As I was mentioning that ECS, the Docker was downloading again and again. Our NAT gateway, went up to like a 28 terabytes. The moment we fixed it, it's down to the 6 terabytes. You can see here, this is one of the examples I can see here that one of the dev environments, I believe. So we use 7,000 hours and it's costing us $88 per month. Let's talk about the Lambda optimizations. We do the basically, the industry standard best practices. Single responsibility for each Lambda. If it is a CRUD operations, yes, we do that for Lambdas. You can see in our repo. Of course, you do the optimizing static initializations, whether it's a variable or whether it's a connections. We do this one. We have almost like a 400 Lambdas. Majority of the Lambdas, I would say, is based on the Golang. Of course, we use the Node, Python, and Java in my company. But I would say probably, around probably 90% of Lambda written in a Golang. We started Golang around probably 2021, if I'm not wrong. in a current solutions, none of us, whether from the architecture team, from the engineering team, none of us had any prior knowledge about the Golang. So we started creating a POC. And then, we have a couple of teams, engineering teams. So we started giving a, hands-on experience to the team. And then we all go and move basically to the Golang actually. So majority of the new developments, we do the Golang actually. Our package size on a Golang, it's 8 MB only. It's a pretty teeny tiny. And majority of them, I would say probably, I haven't seen any Golang Lambda which is declared memory size as 128 MB. The last one, that's the 2024, March 2024, 170 million Lambda executions we have across all the environments, and that is costing us, less than $150. Sorry, I need to do this one. So you can see in this screen, there's 170 million requests. It's costing us $149.40. You can see that barcode. I wrote it, I think one and a half years back, the blog. 100 million requests and costing us less than $100. So you can check it out, that one. It's I put it the entire working examples for the Golangs. You can see the CRUD operations in my example. So if you want to, try to do in your organizations, this is a good examples. You can find it out. CloudWatch. This is the only expense which keeps me worrying about every month. We have a very chatty applications. It dumps 3+ terabytes logs in a CloudWatch. We spend more than $2,500 per month on a CloudWatch. We use 100% AWS ecosystems, that including the code build, code commit, code pipeline, code deploys. So all the build runs in a code build, and if you send some of the outputs, it's gonna go to the CloudWatch and it's gonna cost us. We had so many services where it was dumping thousands and thousands of lines of codes on a code build. So we stopped it. So here is a couple of examples I'm just giving here that how to stop it, that one. So it's not gonna cost us the CloudWatch. So you can just redirect output to the dev null. If there is a steps in AWS S3 copy, just show the errors, no progress. Otherwise, it's gonna dump all the AWS S3 copy commands for all the files. There were so many step functions. Once it's stabilized in a production environment, we just change the the log level to the error only, rather than dumping the entire payload for each steps into the CloudWatch. If it is a Java, you just do the one like a clean package with the queue option, so it's not gonna dump all the output of the Maven commands. We reduce 50% in March 2024. So now it's costing around probably just half of the 2.5K. This is a very simple one, AWS transfer family. So we had a request from the clients that there was a use case where we need to transfer the file. So third party is calling to our SFTP server. So when we did it, it's ultimately what happens. Yeah, you start developing from dev environment to the upper environment, but once it's stable, basically there was no use of lower environment to keep it the SFTP server. SFTP server will cost you like 30 cents per hour, and of course it does not make any sense to shut it down, that one. So as there was no usage in a lower environment, I wrote it one simple step functions, just in case if we need it, or if QA folks ask that, hey, I need a SFTP server in a lower environment for the testing purpose. I said, okay, let me write it down as step functions, which will delete the the entire SFTP basically objects and bring it up at the morning time. Uh, we we basically, when you set it up, it's basically there is a S3 bucket underneath. So we don't delete that S3 bucket. We keep it as it is only. But at the night time, you can basically delete the stack and create the stack in the morning times. Um, we haven't needed any much. I haven't seen any requests from the QF folks. We save $3,400 per year. Just get rid of the lower environment SFTP. But our program is ready. If anybody's asked, we just run simply as step functions. It will create the entire SFTP server. I wrote the blog for that one too, so you can check it out on my blog. About that, that's a working example. So I wrote it that. This is a cost I copied. It's costing us, it was costing us in the $733, but now it's costing us $446. So because of the get rid of the lower environment SFTP servers. EBS volume. This was the easiest one to make a change. Just move your EBS volume from GP2 to GP3. It's right away give you a 20% discounts to you. GP3 volumes, it gives you a 3000 IOPS and 125 MB throughput per volumes. GP2 basically it's used for the bus performance. So you can see here that GP3 costs us around 8 cents gig per month, and GP2 is costing us the 10 cents, basically per month. You don't need to restart your instance at all. You just change from the console or from the CLI using a CLI command. You can change it that one to GP2 to GP3. For the RDS instance, I believe till last year, if your RDS volume is basically more than 100 gigs, they were allowing to change the GP2 to GP3 volumes, GP2 to GP3. But it seems like they made some change. So now for all the volumes, I believe they are allowing for the RDS that you can change these options and you don't need to restart your instances at all. For all our lower environment, we moved it from GP2 to GP3. Of course, we reduce there's unused, a lot of volumes we had it. We did a pretty massive cleanup in our infrastructure. So 21 terabytes to the 9 terabytes, we reduce it. Usually, it's gonna cost you per terabytes probably $100. So you can see in my next slides actually. You can see we had a more than $2,000 per month. We reduce it to probably $800 around. So we saved almost like a $14,760. This was the easiest one. We didn't have to do much, just bunch of clicks on the consoles and you will be good. You will be saving the 20%. Give me a second. I just want to make sure that I'm, yeah. Couple of other cleanups we did it. We remove our AWS business and developer support. We kept it only one account where we have a developer support. Maybe this is not feasible for everyone, but for us, it works out, and we saves almost like $11,000 per year just to get rid of that one. We did it. We took a little risk here, but our services are pretty stable, and we don't need any support as of now. So that's the reasons we just reduce it to the developer support in one account only. There are a couple of unused resources. We get rid of it. We did it. There was a one private CA. That private CA it's a costly $400 per month. So we get rid of that one. It was not at all. We were not using that one. So we saved $4,800 per year on that one. There were unused gateway instances. We reduced that one. We saved $1,600 per year. We were not using X-ray. We saved $3,200 for that one. For S3 storage, we did quite a bit on the cleanup sites there too. We reduced from 17 terabytes to the 7 terabytes. We started using all different storage type, and this saves us $2,400 per year. So this is as I mentioned, that we have a savings plans. We do X number of amounts commitment for every hour. This is the latest one I just captured from the billing console. So you can see here that whatever the number of amounts we committed, we are using 100% utilizations here. So what happened in last year, 2023, you can see here on this. This is a January. I'm saying, so what happened actually, I think February end or March around, our savings plans expire. But you can see before that it was like between 18 and 100. They were, I think, 60-70 cents. We were not utilizing properly. It was an unused one, so that's why probably you will see that 82 and 100% one. The coverage one, you can see right now it's we were experimenting here our savings plans. Also, we have a plan to we have a legacy applications which is using some of the resources. We probably not gonna need it, or we gonna bring down the number of resources probably after second quarter of 2024. So that's why you will see here a little bit ups and downs here, because here also this is the time where our savings plans expire and we were experimenting this one. This is a reserve instance. Same thing. You can see we are 100% utilizing so whatever we have reserved. And you can see here, as I mentioned, that some of the EC2 servers we're gonna get rid of by after the second quarter. So we haven't reserved 100% full capacity because we don't want to commit for the rest of the whole year. So that's why you see here basically ups and downs here. I think I'm good, Samuel. Thank you. Thanks for coming for the presentations. And over back to you.
Great, thanks very much, Rakesh. Right, so I'll bring up my so Rakesh there had a sort of a mixture of some theory and some examples that, of course, goes beyond the traditional typical serverless architecture that I was bringing up at the start, which is why I said it's super interesting, because a lot of those services are kind of approaching serverless. Things like the SFTP transfer family, it's this kind of managed service, and so we need to think beyond our perfect greenfield architectures. We're of course using some legacy AWS accounts, and we should try and reduce the cost where we can internally. Things like RDS. I know a lot of us, myself included, probably using RDS backends with Lambda sometimes. So really, really useful. I'm going to bring up my screen now. This one here. Okay, you guys can see my screen, right? I assume so.
Yes, it's fine.
Perfect. Great, thanks, Rakesh. So I'm going to sort of just bring a little bit of story time from some experience that we've had at Serverless Guru with a client. When we love telling this story, it can show why you should be doing cost optimization, specifically looking at Lambda functions, but at the same time, how it also demonstrates how difficult this can be. That's why most of us are here. We haven't quite sussed it yet. So the story I'm going to tell today is the 100x Lambda. So we had a client come to us, a client that we've been working with for some time, and they said our Lambda costs are through the roof. They've increased 100 times in the last 6 months. You can see the graph here from April up until September. Something's happened, and when you don't have all the observability and all the tooling in place, and when it's someone's job to look at this, sometimes these bills just creep up, and if you haven't set up your billing alerts and whatnot. This is a large company, so it's not like it's going to be one person's responsibility to make sure the company's spending their money wisely. It can kind of get lost in the noise, and it's exactly what happened here. So we needed to step in and we needed to figure out what exactly has happened in these last 6 months. So we found that there was one single Lambda was at fault for that 100 times multiplication in their Lambda cost. And it's this little red guy here. So this graph is the number of Lambda invocations, and it was this little red one because it was about 10% of the monthly invocations when we checked after the 6 months. And you can see in this second graph, which is now in blue, it was accounting for what looks like maybe 60% of the company's total Lambda cost. So we had definitely found it. This Lambda, which was 6 months old, had gone from nothing to eating up 60% of that whole Lambda cost. So great, we found the Lambda. Now we need, as you look at it on the face of things, it seemed fine. What we did is we produced a graph like this. So let me break down this graph a little bit. So this Lambda function has what looks like 13 different sort of code paths it can take based on various external factors. And what we did for each path is we produced buckets of 10-second intervals for how long an individual Lambda invocation was taking. And then the value that you see is the percentage of invocations that were within that bucket. So let me use an example here for path 1. We can see that 88% of all the invocations of path 1 fall within 0 to 10 seconds of an invocation time. Going to path 3, you can see that all of our Lambda functions invocations were taking less than 10 seconds. Now, everything that is in red is something that took longer than 30 seconds, because I'm just showing you one half of this graph. There was another half, what you can see here. So this Lambda function had a very long timeout set. I believe it was 4 minutes. And you can see here that there are a few, these are percentages of percentages. This is 0.1%, 0.04%. And you can see here that we started to see a pattern. Why were some of these Lambda functions hanging right until the end of their timeout? Some were even timing out. Some were genuinely completing, but taking in the orders of 200 seconds. This was definitely the cause. To give you a bit more context, this Lambda function, it was deployed initially with some slow onboarding. And so, as I warned, big enterprise customer, this Lambda was getting about 50,000 invocations a day. Now, as the adoption of this Lambda function picked up over the 6 months, that number grew from 50,000 invocations to 5 million. So these percentages here, they're fairly sizable. The percentages as a whole, they equated to 1.67% of the Lambda invocations. And so when we get to the end of that 6 month period, 5 million Lambda invocations a day, that 1.67% equates to 83,000 seconds, or 83,000, let me get the numbers right. Yeah, 83,000 invocations. And you saw a lot of those invocations were taking in the order of 3 to 4 minutes. So in terms of Lambda compute time that you're paying for, it's in the orders of hundreds of thousands of Lambda seconds. So we did a little bit of waste analysis, as you can see here, and those Lambda functions taking over 30 seconds was costing the business around $10,000 a month. And as a reminder, it's less than 2% of those. So what do we need to do? First of all, we need to cut that time limit right down. That timeout. It's set to about 4 minutes. We managed to convince the business. It's a large enterprise, and they're a little bit scared. I'll give a little bit more context. Let me back a couple of slides. So why were these invocations taking so long? The reason was as a downstream API that was extremely slow, and it became even more slow when put under load. And so as our invocation count grew from 50K up to 5 million, the amount of times that we were going to be sort of throttling this API grew relatively. It grew to the point at which you see what we have here. So we decided we're going to, and to be honest, when a Lambda function takes this long to run, I think most of them were synchronous invocations, maybe behind API gateways. The API gateways timed out at that point. So we did not need to sit here and wait for these Lambdas to eventually get a response. That response has been disregarded into the void. So we made the decision we were going to bring that timeout right down to roughly 30 seconds. It was also deployed with 4 gig of memory, which is very large, especially for this Lambda function. And now I spoke about power tuning earlier, and we didn't go down that route initially because, first of all, for a few reasons. First of all, it's a fairly complex system at these large enterprises, and if you really want to test this Lambda function with its performance, you need the whole performance teams. So running power tuning is great with a couple of events, but this thing behaves differently under stress, and it's very difficult to replicate that via power tuning. And secondly, we needed a whack fast. This is costing $10,000 a month. And we already had the information that we needed. We already had sort of the memory usage spread. And we can see here that the vast majority, or all of it, wasn't going to be utilizing anything over about 1500 megabytes. So we decided to resize it to 1536 megabytes, which means that if we are sat idle, as I mentioned at the start, we're going to be incurring less of a cost. And then we also cut that time out right down to around 30 seconds. And so any of those throttled API requests are just going to be thrown away, and we don't pay for them. So it ended up being 62% cheaper. We saved around 6K alone on the memory sizes. So taking into account the timeouts as well, we were saving the company $15,000 a month. And so just to recap with sort of a few points about why this was so difficult. Why is it a difficult story that hopefully a few of us can relate to? That Lambda function was harmless when it was deployed at 50,000 invocations a day. And as we move from project to project, it's something that's a benefit and also a curse when it comes to serverless, is that you can build an API and then you can move on. And the ownership of these applications can become quite vague. And so what's clearly happened is somebody has deployed this. It's gone through all the performance testing because it was absolutely fine. But these Lambda function invocations that at 5 million were taking around 2% of them were hitting that throttled rate. I'd imagine that the 50K, and we'll never know, at that 50K rate, maybe we weren't seeing it at all. Maybe that downstream API behaved just fine. But even if a few of them were coming through, they may have just been disregarded as outliers. And when a Lambda function gets to 5 million invocations a day, all of a sudden that 2% of invocations can equate to hundreds of thousands of Lambda of Lambda invocation seconds per day. So I think that's everything from this slide. So what do we do? The third point. So we looked at the logs, and we saw a few of them were taking more than 4 minutes. I think this is quite a wordy slide. I apologize for all of that. I think I've pretty much covered it. Pretty much managed to save on a single Lambda 15,000 per month enterprise level by so the first thing, we didn't get to identify it. Well, the client identified it and came to us. They obviously came a few months too late. Maybe after a couple of months, they may have been able to save the annual salary of an extra software engineer. And then after that, actioning it. So it's about looking at that Lambda function, identifying why it's taking so long, and then making those business choices to reduce that timeout and properly size your Lambda functions. That's it. So story time over. I think we would probably open for questions, but I can see Rakesh has been answering a few. Alan, I don't know whether you wanted to come back on the screen to help chair these. Just let me know. Let's read what we've got in the chat so far.
So one of the questions was, whether it's a user facing functions or whether it was a backend API was calling our Lambda function. So majority of our work is the backend API is calling the functions. We have probably a one or two maybe customer facing functions. So it's all backend API.
Just catching up on the on the chat. I don't know whether you had any questions that you'd lined up from here. Sorry. No. Feel free to come back off, and that's absolutely fine. I didn't know how these things go.
That's an interesting question. Um,
Rakesh, do you have an answer?
Not in my top of my head. Just thinking.
I'm
No.
gonna have an answer. I have no way of backing it up with facts, by the way, but this is just kind of from my intuition and sort of vague memory. But I think a lot of us, when we go to use something like DynamoDB, we automatically go to that on-demand setting because it's just great for setting up a greenfield where you haven't really done much capacity planning. You don't know whether your application is going to have 1,000 requests a second, 10,000, and so on. And then the application gets mature, we build it, and as I said, we tend to move on. And I think there's an opportunity that maybe a lot of people overlook of moving to a provision mode because those RCUs and WCUs becomes maybe it's the storage. This is the bit I don't quite remember with the numbers. It becomes so much cheaper, and of course now your application is mature. You have the capacity planning. You have all of those CloudWatch logs, CloudWatch metrics. So that'll be my answer from my experience. A tendency to sort of leave things on demand and not take advantage of some of the provision modes.
It's a really good one, and I can speak from experience that people don't often do that. It's when you don't know your traffic, when you don't know what that's going to be. Uh, AWS recommends, yeah, just use on demand because it'll scale up and down for you, and then you'll get traffic in your system. You'll understand the numbers, and then you go into that on demand phase. Coming back to that, and not even just that, any band-aids you put in your code, coming back to like literally anything in software development almost never happens. So it's an interesting trade-off. You really have to put that stake in the ground to say, yes, we are going to do that when we have the numbers. And then you also have to quantify, what does that mean? We have the numbers.
Correct. I can tell you that it's not related to this one, but this is our experience. We did a massive cleanup actually, and to be honest, we blew up one of the dev server, and it was a given a wrong name like a CF EC2 server, and I was an impression is basically a cloud formation, but it was a cold fusion server. We had an alternate, so we don't have any issues, but we learn a lessons over there that after that points we if possible we take an example. If it is ABS volume, probably you detach that one, keep it for a week or two, and then probably go and delete it. If it's a EC2, probably you shut it down, take a AMI, and then keep it for 1 week, 2 week, and then delete it. So that's the hard lessons we learned it, that don't make it any actions immediately, keep it, and then do it later point of time.
I like what uh, Ziad said in the comments. I think he was joking, but it's actually really good advice. He said, "Don't build new services." Which we're all in the serverless game here. I read that as take advantage of people who are willing to do it for you. Don't reinvent the
Correct.
wheel.
Correct. I'm say from 21 onwards, pretty much all our new development, it's all serverless. We don't have any more new ECS services. It's 100%, and basically we use heavily Lambda, DynamoDB, step functions, and OpenSearch pretty heavily.
Do you have any cost optimization tips for OpenSearch?
No. No.
Okay. Have you tried the serverless offering of it?
We thought about it. but I think from the cost perspective, it's probably going to cost us a little bit more. So we haven't gone through that route at all. Yeah.
All right.
I think there are a couple of good, just a couple of questions that I can see. I might as well address whilst we're here with a couple of minutes. Victor, so Victor asks, I think he's probably talking about my 100x Lambda, about whether we could just call use the third party API step function step. Yes, we definitely could, but I just think the effort to sort of re-implement the Lambda function that we had there. Also bearing in mind that this Lambda is running like 5 million invocations a day. I don't think step functions is the cheapest service, and so we don't tend to use it for some of these like high throughput bits of data processing. So I think, to be honest, I mean, we haven't. I think the best decision to do is to just cut the invocation there. If we're not going to get the response back within, I think my slide actually had it. So there's apparently this is behind the CDN with 120-second timeouts. So if we don't get a response in 120 seconds, then it doesn't matter what we do. It doesn't matter how much cost we save. But wrapping the whole Lambda and everything and adding all those state transitions, I think probably inverse the cost savings that I probably just mentioned. I saw another really good point. I wish I'd come up with this one because this is something that I strongly believe as well. Log retention. That's a great way of saving costs. Everyone seems to complain about CloudWatch and how much it costs. I think we like to log a bit too much. I don't remember the last time I have a service that I disabled the info logs. I like it helps me sleep better at night when I have those info logs. But definitely they cost a ridiculous amount of money. I think we try to use like custom loggers that sort of send our logs into S3 and then query via Athena. I think we tend to find it a little bit cheaper, but the user experience isn't quite as nice, and you've got more code to maintain. So that's one way that we try to get around it. But I personally, and we normally just enable that behavior for production for everything lower environments. We just sort of suck up the cost in CloudWatch. Yeah, log sampling. That's a really good idea as well. Yeah.
Yeah,
I think go on, Rakesh. Go on, sorry.
Yeah, Omid was mentioning that one. Yeah, and we kept it lower environment OpenStretch, a single node only. Production is having a 3 nodes, so to make it reduce our cost in lower environments.
Okay. Sam, I think you were were you wrapping it up? Oh, hold on. Let's Praveen has a question. Let's get him on to ask, and then I think we're good. It's gone. His request to speak is gone. Do you still have a question? There we go. Okay, let's bring him on.
Hey, Alan, can you hear me?
Yes.
Yeah, thank you. This was a lovely session. I came to know a lot of things. I have one thing which I think we missed it. Like we have AWS scheduler instances for EC2s, which is saving a lot of cost for us and lower environments. That is the one which we are trying to implement in all our lower and mini prod environments, where like currently T-Mobile uses a lot of customer rep EC2 instances, the stores doesn't run after hours. So all the store softwares get shut down on the scheduler instances basis.
Correct. Yeah, that's a nice options.
Nice. Okay, Alan, shall I go for the rat? I feel bad for bringing you on. This I haven't had the chance to attend too many of the sessions here on Believe in Serverless. I didn't know how it would go. I guess thanks everyone.
It's Alan's birthday, so you're fine.
Yes, yeah. We should somehow let's bring everyone on. Can you bring everyone on and we can all sing happy birthday?
Yeah, that's right. Yeah, everyone that's still in the audience, I'm going to bring you on one at a time, and you can just wish me happy birthday directly.
Nice.
Okay.
Thank you.
Yeah, go ahead, Sam. You can wrap it up.
Let's drop.
Okay.
Yeah, let's drop. Thanks everybody. Pleasure to be here. Deliver my first piece of content for Believe in Serverless. Hope to do a little bit more. It was great to chat with a few people on the stream. Thanks Alan and Rakesh for giving me the opportunity to come co-host. Thank
Thank
you.
you so much. Really appreciate it.
Yes, thank you both very much.